All right, let's hook up some different types of toggle switches. We have simple, these are all automotive, on, off, right? And then we got a on, off, on style. And then we got these illuminated types. Whereas if you hook them up to power, they illuminate when you turn them on and off. That'd be pretty cool when if you guys got a darker room and you want to see something on and off. Just another style of a switch. So we'll show you guys how to hook these up for the simulator. And then I think after these style of toggle switches, we'll get to the rocker style switches with the beacons and all that fun stuff. We'll get to that in a bit too. But let's go ahead and see how these are fairly easy to wire up. We will need the relay board because we will need a primary and secondary output for one switch. So I filled this in a little bit more. So with our switch off, switch is off, switch is on here. One switch, off or on. If it's off, then this happens. With our relay board, we'll have a normally closed common switch that'll be shut. So you can use this as your primary or secondary key binding. And then when you flip the switch, now the switch is on. Now your other side of the relay works. Your common to normally open circuit is working, and you can use that for your primary or secondary key binding assignment as well. So one switch, again, on or off. One switch, primary and secondary keyboard assignments is what we're going to do. Okay, we have our relay board that is with live power. We have 12 volts feeding the yellow wire going to the 12 volt circuit, and we have our ground going into our ground terminal. So these are what you call spade connector terminals. Get yourself a spade connector terminal set. Well, this has more than just spade connectors. You may want to get a whole assortment. With something like this, they've got 3 different gauge sets. We've got red, color-coded in red, 22 to 16 gauge wire. This is an American Freedom units. Well, I don't know what you guys use in other countries. Blue is the next size up in wire. That's 16 to 14 gauge wire, so it's a little bit bigger. And then the yellow will be your 12 to 10 gauge wire. You won't need the yellow bits. You'll be sticking to either the red or the blues. The yellow ones are pretty honking stuff. It is meant to go on some pretty dang fat wires. Now, I bought this. This comes out of my service truck on my automotive channel, so this is just the whole kit caboodle. But you stick with these, you'll be fine. You do want some round ones as well, because when we get to the ignition part of it, it's going to require round connectors to hook up to those studs. We'll get there. We'll get there in the same video, guys. But for now, we'll just use the spade connectors, and you can see the difference in the gauge wiring. You'll just have to match up with whatever gauge of wire you're using. Now you can use the blue type. I got much thicker. I got what, 16 gauge wire here, so it should crimp on okay. If sometimes you tug on it and it comes off, and if it comes off pretty easily, you may want to switch to the red one, a slightly smaller one. As you can see, I can just barely squeeze it in here as well. So after you crimp it, which I'll show you how to do, and then your connector still likes to fall off after a gentle tug, maybe we'll go the next size down for the wire. No soldering is required. We're just going to do crimping. I like soldering myself, but what we're doing is strictly in-house stuff only. Nothing's going to get rained on, so we're not worried about weatherproofing stuff. So what we're going to do is we're just going to shove it in the O, like here. You should see a little bit of copper protruding from right there. Grab your wire crimpers, link in the description down below. You can see we have the red, the blue, and the yellow. They're all color orientated with your connector. In the US, it's pretty standard. I don't know what you guys do outside the US. So then, I like these crimpers because you can crimp down so hard, nice and crimped, and if you push a little bit more, you cam it over and it automatically releases. I really like these, even though these are the Chinesium type. These are really, I really like this crimper device. And if you're crimping down and you say, oh no, I don't have it lined up quite right, there's emergency release. Just trigger it, it'll pull right back up without you having to push it all the way down and ruining your connector. So I know the blue is the middle jaw set. You guys won't be able to see it on this side, but... So then I just aim it as best I can. And I know I don't like that too much. I'm going to use my emergency release here. I call it emergency release, I don't know. Quick release. I'm going to reposition it a little bit and crimp. And it's crimped. Give it a little tug test. Ah, now see, you see that fell right off? That's no good. So I got a reg connector here. We'll just shove it all back in the air. I can just see the copper coming out of there. That's already a much tighter fit. Let's try the red side. So on our crimp, it's going to be the full forward position. So let's do it on this side for funsies. There we go. Off. Yeah, I'm pulling it very, very hard, and it's nice and taut like a twiga. Excellent. And then all you simply do, most of these spade sizes are standard size, you just slip it onto there. Okay, again, the copper is just starting to poke through there. That's all right. You don't need to strip a whole lot off, because if you strip too much, then you're going to have bare copper wire being exposed beyond the sheath, and you could short something out. So when you're stripping it, don't get too crazy. So then we'll just crimp it again. Okay. Just a gentle tug. I'm pulling with all my might, and it doesn't want to come off, so that's good. And this is the hot switched side now, if you will. And simply hook it up to any number of one of these terminals here, whichever terminal you want. So to reiterate, we got a 12-volt power supply, not only feeding our board, also feeding our switch, live 12 volts into here. The other end of the terminal is going into our power relay block, if you will. I'm using terminal 5 on here, and that's turning the relay on and off on the control side, which is flipping switches on the load side here without putting any of the 12 volts over here. So 12 volts, and by the way, you can swap these terminals around for this switch. It don't matter. The relay has a normally open and normally closed circuit, and it is screen printed on here. Normally open and normally closed and common. So now that we have two switches, we need to wire them up to here. We go over to our corresponding number 5 relay. We're going to hook up the buttons up first, the actual buttons. We'll hook the common wire up next. Okay, with that connected, so this goes to button, whatever button 1, button 7. This will be like button 1 and basically button 2. Primary function and secondary function. And you can swap these around, that's fine, because you can program it backwards into the simulator to make it right, so you don't have to worry about getting the wiring too wrong. One is the normally opened, and one is the normally closed circuit on here. Okay, this black wire will represent our ground. The middle one on this particular board is the common. So now we have our ground strap again that we'll hook up in a minute. The theory is your ground coming from your game controller board will come into here as the common. And then if you have your relay on or off, will dictate if this button gets grounded or this button terminal gets grounded. Primary action and secondary action when you're programming it. So basically I have one switch, you get two switches. Pretty cool, eh? We'll take our actual button pins, if you will. That goes to our button terminals. For this particular board, the actual buttons are on the inside. As you see here, that's your standard buttons. That goes on the inside of the board. This is our ground. That'll come from our game controller board. That's just the other side of the switch is all it is. So we'll hook that up here. Hook that up there. Okay, now we have 2 buttons we can use, or rather we can use 2 actions for every 1 button. So once again, we got 12 volts coming from our power supply into the switch, 12 volts coming on or off out of here into one of our 8 terminals here. I've chosen terminal number 5 just because whatever, it's available. And because that relay turns on and off, we have a normally open and normally closed circuit action happening here. The ground is coming from our green wires hooked onto the outside of our board because that's where the ground plane is at. Coming in here into 1 ground here because there's not 2 terminals here, so you got to share it via junction terminal. And then that ground's either going to get pushed out to one of the buttons. If you have the relay turned on or off the other way, then only the other button function is going to work. So you got button 1 and button 2 now being sent over there. And the white and gray wires are connected to the inside of the board because that's where actually the button logic goes into the memory controller. Okay, so we're going to go to keyboards and buttons. What shall we do? Hazard warning? Sure, why not? So click on hazard warning, and we'll go ahead and flip our switch here, just one way. We don't want it. We don't want the hold feature. So, or do we want the hold feature? I think we do want the hold feature actually. Let's click on here. Let's do that again. Let's cycle. Okay, now it says hold. That's fine. And on the other side, we'll go ahead and flip the switch back to the way it was. Click, and then pull the switch the other way. And that's the other button. It says hold, perfect. And then we'll switch that button again. And now it should, in theory, be programmed. So let's go ahead and get in our KW and see what we've got here. Oh, I got a beet harvester I'm supposed to deliver. Well, it's not going to get delivered today. All right, let's get some electricity served up. Right, now we're going to throw our switch. And hey, look at that. We got switches. We've got, oh, we got headlights. We can't see that too well. We can see we've got flashers, right? Turn them off, they don't work. Turn them back on, they work. Now, if your button is wired backwards, it's not a big deal. This applies to latching switches only, not the momentary press. Just for latching buttons only. If you notice that your button is backwards, meaning the button's on, but nothing's happening in here, the wire is wired up backwards. So this would be on and that would be off. If you notice that it's flip-flop backwards, really easy to fix. Hit escape, throw your switch the other way, and boom. That fixes it. You don't have to reprogram it or rewire it. It's really that easy. And if that doesn't work, then you'll have to go in and swap your primary and secondary key bindings. But before you do that, try that trick first. If your button or switch is backwards, just hit escape, flip it the other way, hit escape again, and that should flip it right back up again. Okay. And you can fairly give it about a second for latency. Don't go faster than a second, but that works just fine. As you can see by our diagram, they do work when the switch is on and the switch is off. Now let's upgrade this guy from a single throw here to a double here. So on, off, on, off. The only thing that immediately comes to mind where you can use this perhaps is the suspension up and suspension down. I mean, you could wire, it's just a switch, you can wire up any 2 different functions this way. Let's go ahead and wire this up. Now you notice here, we got slightly different terminals here. I don't know if you can really call these spade terminals because they're really not designed for spade connectors. I'm not sure what you actually call these, but these have little screw inserts here. So this is where those circular terminals come in, such as these guys. And they come in different flavors. Just find one that's closest to the diameter of your screw. Alternatively, you can get these fork style ones as well. Jam it in there. They'll work too, but it's open-ended and it can fall out, especially if you got motion simulator. And now that might be a vibration possible issue. So I would suggest the round terminals would probably be best for the situation. This is the smallest size that I have, and you can see it easily slips over to there, so that's fine. Let's go ahead and crimp that up now. So now we have a hot wire coming in from our power supply, and now we have 2 hot outputs, depending on our switch, if it's full up or full down. And that will control 2 relays this time, which you'll see here in a second. So now we just need to hook up our power and do one of our relays. So we'll do number 5 again, because I already have it hooked up to the game controller. So now, just from a distance, because this has nice LEDs, we can now control 2 relays. We're basically doubling up. We got 1 relay there, we got another relay there, with center being off. So if you guys are visualizing this, switch on, switch off, switch on, and switch off. And now you got a normally open and closed circuit here, and a normally open and closed circuit here. So now, for the magical art of relays, you now have 4 buttons you can choose from to control whatever. 2 buttons here and 2 buttons here. Normally open and normally closed, normally open and normally closed. Remember, all the voltages stay on this side of the relay, and the other side of the relay is just switches for whatever magical stuff you're having happening over here. All right, now we have 4 functions wired up for the simulator. First of all, we'll make sure our relay board still works. Yep, so our 3-way switch here is working properly. Okay, basically the same thing we did with the previous switch, only we're just basically doubling the capacity while still being a single switch. Right, overview. Power comes in through here, as we discussed earlier, through our power supply. We're over here. This is power in, going into there. Now, depending on which switch you throw, they'll throw 12 volts here, or only throw 12 volts here, one or the other here. Either which one you choose will get wired up to your relay board, which will turn either one relay on or turning on the other relay. There's a normally open and normally closed circuit here, and there's a normally open and normally closed circuit in this relay. The metal terminals here are your common ground that goes to the ground plane. Every controller board, in case with the Leo board, it's the ground plane is all on the outside. So I just matched it up with the pins accordingly. Let's follow just the ground logic here for a second. We got 1 big fat wire going into the common for our relay board. And this is just a splicer unit, because there's only 1 terminal on these relay boards. So the relay section, so the ground section comes out of here. Gets split into 2, and we're using 2 pins on here. You can get away with 1, but I like using both pins because they're there. I don't have to worry about more ghosting. I can ensure that the ground signal gets all the way through. So that's on the outside of the board. Grounding wire, grounding pin. The grounding pins are all on the outside for this Leo board. Yours most likely will be 2 different varieties of flavors, but I can't guarantee it. But there will be a grounding plane. So we take our grounding plane, shove it over to our common terminal, which is the middle terminal on this board for the relay. And with your switch turned on or off, it will dictate if this ground signal is going to go to this button or if it's going to go to this red button here. And those 2 button wires get simply wired to the inside of your board, like this. And of course, since we have 2 relays hooked up, it's just mirrored once again. We have a ground strap here going to our grounding pins, which are on the outside of this board. And we have 2 more signals, normally open and normally closed, for buttons 1, buttons 2, or primary function and secondary function for us in ATS and ETS2. And that goes on the inside of your Leo board. Now, as you can see, we're getting a little bit more complicated, but not really switching. But we're getting a little bit more wires, a little bit more logic going on, but again, it's just a rinse and repeat based off the same method I'm doing before. Now let's wire up, let's do suspension up mode and then suspension down mode. Let's click on this and let's just throw this switch up. Okay, it wants to act like a button. This may not actually work for our intended purpose. Actually, we might be able to. Let's do suspension down. This doesn't have the hold function. You see how the hold function isn't coming up? Let's just see how this acts. So let's see what happens. This may not work because it's I don't have a hold. So we turn the switch on and turn it off. So it stays on. Switch down, we'll enter into low. Okay, no, that will work then. Okay. Now, when you're driving, I should note, when you're driving down the road, like above 15 miles an hour or so in the truck, the suspension will just reset itself. But that will actually work for suspension up and down. So you want to hit them switches. You got suspension up. We turn it off. It actually stays locked there. It remembers which position you wanted it. And then switch down will be suspension lower command. Sweet. Okay. Well, that does work then. Okay. Okay. Now let's see what it takes to hook up a lighted lever switch here. Okay, with these particular switches, fortunately they are labeled for us. We'll need to ground it because LED needs a ground and 12 volts to operate. So basically, ground wire here, positive 12 volts here, and then our on and off switch is this terminal. So hook up our ground wire up to the ground terminal. We'll use this as black for ground or earth, as you say, for non-US folk. And then we'll need a positive 12 volts coming in here like we usually do, which according to the label is the other outside one. Don't mess this up, otherwise you might burn out your LED. Be very careful, watch your labels, make sure you know what you're hooking up and know the theory first. There's more than one time I let off magic smoke. A little smokage, yeah, yes. This is coming from my power supply. So positive 12 volts there, and I'll have to get a ground clamp from my power supply. Okay, so now in theory, yep, okay, we got illumination there. And that illumination, when it's on, also tells us that there's going to be 12 volts on here, which will go to our relay. So if we hook this middle tab, or this middle terminal, will actually be our commanding on and relay to command to turn on and off. And let's just do relay 5 because we use and abuse it. So now if we wire it up right, the switch will glow and the relay turns on. Simple as that. And then of course, again, nothing changes on the game controller side. We still have our common wire from our common ground plane on our Leo board, which is the outside pins. I just pair them up with the button side, but we just hook up our ground pins into a single wire going into the relay because they don't have two terminals. And then button 1 and button 2 will be going from here into here, or whichever terminal you want for your button side. It really is that easy, and hook the switch up to whatever you want. That pretty much wraps up the lever action, if you will. Lever switches. Let me reset a few things, and then we'll get to do some more fun automotive switches. Looks like we got hazards, we've got beacons here. I'll show you how to wire these up because there's a little bit more shenanigans going on here. And I think after we do with that, I'll show you how to hook up the gang box here, which we've got 4 here as well. I'll show you how to hook that up. All right, resetting, be right back.